The past few months, you've probably heard terms like metaverse, NFT, Web3, and blockchain, but you might be wondering, what do those words mean, or what are their use cases, or maybe why is everyone excited about that? So let's talk about them in details in this video. So just like me, you might be wondering, where does the term Web 3.0 come from? And you might be wondering, maybe we had previous versions of the web, like Web 2.5, something like that. And yeah, you're right. We've had like three major breakpoints in the web evolution. We had Web 1.0, Web 2.0, and now we are having the Web 3.0. So let's take a look at those three breakpoints and what made them, what made those changes. Let's start with the first phase of the web, which was Web 1.0. So at this stage, the web was just read only. It's more of you're reading a magazine, but on a computer. Then we had the second phase of the web, which was Web 2.0, which was read and write. And that came with social medias and e-commerce, where you can post something online, edit and delete. And now we are currently moving to the third phase of the web, which is Web 3.0, which comes with decentralization, ownership, and all those stuffs. So let's quickly jump in and see what brings that current state of the web. Before we talk about everything Web3, let's take a look at what are the odds in the Web2 ecosystem. So we are having big tech companies that hold users' data and use them in some unusual ways. That's why people no longer like that way of leaving their data or exposing their data to the big tech companies. That's why with Web3 we are seeing that new ecosystem where you don't have to share your data to access some part of the web. So in simple words, we are having what we call decentralization, where the data is not controlled by any single company, but the data is controlled by multiple nodes around the world. And by nodes, we mean computers that are around the world. And that's run the EVM to run the blockchain technology. So let's quickly talk about the blockchain technology. In simple terms, the blockchain is a sort of database where everyone has read and write access, and the blockchain is not controlled by anyone. Rather, it's run by multiple nodes around the world. I think for the Ethereum blockchain, we have around 3,000 or 2,700 nodes around the world that run the Ethereum EVM, the Ethereum virtual machine. The way that the blockchain works is that every transaction is recorded on the blockchain. That means every interaction with the blockchain is recorded, or every writing on the blockchain is recorded and stored somewhere with an address and a hash. And as the word if we split the word blockchain, we get two other words, which are block and chain. So that means all the transactions are put together in sort of blocks and they are chained together. That's why you have the blockchain. And each block has a hash of the parent block, so that we get that chaining. So the second block has a hash of the first block, and so on and so forth. So this process of storing data on the blockchain is done by two mechanisms, which are proof of work and proof of stake. So let's start by talking about proof of work. So basically, proof of work is a mechanism where each node on the blockchain try to solve a puzzle to store data. It's a sort of an algorithm where the node that solves that algorithm first will be the node that will validate a block and get reward in cryptocurrency, of course. So like for the Ethereum blockchain, which is still using the proof of work, the node that solves the puzzle will be the node that will validate the block and get rewarded or get some reward in Ethereum or in Ether, which is the cryptocurrency of Ethereum. And basically this mechanism is energy consuming and transactions take long to be executed. So with the proof of work mechanism, we're having some issues scaling to the number of transactions that are being executed at a certain time. That's why the gas fee on Ethereum is very high. So due to the fact that this mechanism is energy consuming and gas fees are high and transactions are very low to, the load time of the transaction is very wide, we are having some alternatives like proof of stake. So let's quickly talk about the proof of stake and how it works. So for the proof of stake, we are having nodes around the world or validators that stake their cryptocurrency to get a chance to be the one to validate the block. That means each node stake its currency to get a chance to be the one to validate the block and update the whole ecosystem. So the node that validates the block, updates the blockchain, will be the node that will get the reward. So this protocol is not energy consuming because all the nodes don't have to go through the same process of solving the same puzzle to be the one to validate the block. So in this case, one node is just selected and that node will be the one to validate the whole block and update the blockchain in order to get the reward. After talking about the consensus mechanism, we are now going to talk about smart contract, which for developers who are in the ecosystem, they have heard about that for a long time. So what a smart contract? Basically, a smart contract is a piece of code that lives on the blockchain and execute a certain task. And the good or bad thing about a smart contract is that once it's on the blockchain, it can't be changed and it will live on the blockchain forever. So maybe if your smart contract, or the purpose of your smart contract is calculating 1 + 1, that smart contract will calculate 1 + 1 forever and that will never change. That is the good or the bad thing about smart contract. It just depends on how you see that. But smart contract, most of the time, they're just small pieces of code, because developing smart contracts, you have to make sure your smart contract is not taking that much gas fee, because everything, writing on the blockchain costs money, and in money, I mean real money, but in sort of cryptocurrency. So if you're developing on the Ethereum blockchain, you'll be paying in Ether, which is the cryptocurrency on the blockchain. And Ether has a value, okay? I think by the time of recording this video, 1 Ether is equal to 4,400 or 4,500. It's just turning around there. So if you develop your smart contract and it's not optimized, you might find yourself paying thousands of dollars on that smart contract, or not developing but deploying that smart contract. So that's why smart contracts are most of the time small pieces of code. Then that brings us to the next question, which is how to develop smart contract, okay? Which language to use. So for the Ethereum and Ethereum compatible blockchains, we use Solidity, okay? Solidity is the main language, followed by Viper. And if you want to know more about Solidity, I think I'll make some tutorials in the future about that, or you can simply check the documentation about Solidity on the internet. So we also have Viper, which comes after Solidity. It's not that popular as Solidity, because it's most turned on the Python side. So for other blockchains like Solana, they use C++ and Rust to develop their smart contract. And I think on Solana, they are not called smart contract. They are just normal programs. After talking about smart contract and how to develop them, the next step we are going to talk about tokenization. And I'm sure you've heard of fungible tokens and non-fungible tokens, or NFTs. But what do those words mean? Because I know most people confuse NFTs with digital art, right? But fungible tokens are basically tokens that can be interchangeable. That means where one token is equal to another token. Let's take an example of cryptocurrencies. Those are example of fungible tokens, like the ERC20 token. So this means basically you can have one token and change that to another token. Let's say you have one Ether and you'd like to get some Matic, or you'd like to get some, I don't know what some Polkadot. So you can change one, you can trade one Ether to a number of Matics because they're of the same sort, okay, and they're fungible. That means they are interchangeable. These fungible tokens have been widely used in DeFi, and that is the biggest use case of fungible tokens is in DeFi. So next, let's talk about non-fungible tokens. Basically, if a fungible token is interchangeable, that means a non-fungible token is non-interchangeable. That means you cannot change one NFT to another NFT because they are non-fungible tokens. And basically, or widely, these NFTs are used where ownership is required. And one of the best use cases is digital art, where you have one digital art or one NFT that you cannot change to with another digital art. Let's take an example of CryptoPunks, okay? CryptoPunks and CryptoKitties, right? You cannot change one CryptoPunk to one CryptoKitties. It's just impossible. That's why they are called non-fungible tokens. And the best use case, those tokens are widely used when it comes to ownership, okay? When you want to prove that this digital art belongs to someone, or the owner of this digital art is this address. That's when NFTs are widely used. So if you just go to a website like OpenSea, you will see digital arts that belong to people, and sometimes those digital arts are sold for millions of dollars. We have seen that, we have seen CryptoPunks sold for millions of dollars, and we have also seen a digital art called The First 5,000 Days that was sold for $69 million. That means the NFT world is really exciting and an amazing world, or an amazing technology to look at or to go through. So now, after talking about tokenization, let's talk about Dapps. Okay, this cool world you hear everywhere. I've developed a Dapp. This is a Dapp. But what does Dapp mean? Basically, a Dapp is an application that is decentralized. Okay, so the D stands for decentralized and app for application. So this means that a Dapp is an application that talks to the blockchain, or the application that is powered on the back end with a smart contract. And we have seen thousands of applications that are powered by smart contract, or that live on top of the blockchain on the back end. Okay, we have seen applications like OpenSea and all those other applications like Air NFTs or Raribles, and there are so many applications that are Dapp. Okay. The really difference is that a normal application might have a front end and a back end powered with Node.js, PHP, and so on. But a Dapp is powered on the back end by a smart contract that lives on the blockchain. That's basically the difference between a traditional app and a decentralized application. And the good thing with decentralized applications is that they're not controlled by any centralized. In most cases, they are not controlled by any centralized entity. Okay, that means the data doesn't live on one single server, but it lives on decentralized nodes around the world. And then lastly, you might ask yourself, how do these applications work? I mean, how does a front end that is maybe a web app can communicate with a back end, which is a smart contract and lives on the blockchain? And that's a good question. So we have APIs like ethers.js, web3.js, and web3.py, which are APIs that makes it possible or make it possible for a front end and a smart contract to interact or send transaction, query data, and so on. So basically, that's how there is a connection between a smart contract and a front end. And in most cases of Dapps, the front end will be a web application in most cases, not in all cases, but that happens in most cases. So guys, that's all I had for you today. I hope you got a brief and quick overview about Web3, about consensus, about blockchain, about NFTs, and all those stuffs. So if you've made it this far, thanks for watching this video. And if you have any kind of question, any kind of addition to this ecosystem, feel free to put a comment below, and I will reply to that comment as soon as I can. So guys, again, thanks for watching, and I'll catch up with you in the next video.